This is a video demonstration for refraction experiments option 1. Firstly, the materials that we will require. We will require some colored tape, a ruler. We can also use some kind of chopstick or some kind of long stick, a container to put water in, some scissors, a cell phone or any kind of camera, and some water. The first step is to use the colored tape to mark some height on our ruler. Here I'll be using a height of 4 centimeters, so I will cut my tape 4 centimeters and wrap it around the ruler that I have as it is shown in the video. You can also use any kind of board marker, dry erase markers, any kind of permanent marker if you have one, to mark any length on your scale. Just make sure it's not, very easily erasable and won't, rub off as soon as you dip your scale or ruler, stick, whatever you're using when you dip it into the water. Just make sure that doesn't happen, and anything else would work just as well. It's just you need something to mark some kind of specific length on your on the kind of stick or ruler or whatever you're using. Right, as is shown here, so clearly it's about 4 centimeters. Just getting my camera to focus. Right, so here it is, it's 4 centimeters. Right, so now we will try to tape this to the inside of the container that we will fill with water. Now for this purpose, what I did was I basically taped my ruler with some Scotch tape. Scotch tape I used because, well, it's transparent and it wouldn't hinder the view of the red tape, and it wouldn't alter it in any significant way. What else you can do is you can tape it to the bottom, just any way so that it sticks, it doesn't move. So any way you can think of, maybe like have some kind of plasticine that you put at the bottom of the container to make it stable. That should work just as well. You just need it to not move, basically. So I just used some tape because it was the easiest option for me, and it works pretty well. Right, so now some technical things here. Wherever you're going to place your container, you should make sure that you don't move the camera like I'm moving. Or if you do move the camera, you don't move it before and in the time between you add water. You shouldn't move it. You shouldn't change your magnification. You shouldn't change anything. So here I have fixed like this position for my camera, and I'm not going to move it. Well, I'm going to move it after the second because it wasn't as clear. So I just took a book and made it a bit elevated so I could see the entire length more clearly. As you can see, it's more centered, more visible here. So now from this position I won't move it so that it doesn't mess with my measurements. Now I'm adding some water into this, and as you will see, the 4 centimeter length height before was a lot longer than it appears in the camera now, and that is what we are trying to observe. We are trying to observe refraction, and this is the apparent height of the 4 centimeter tape that we added. So this is not the real height, right? So I'm just gonna top it up, but just a little bit more water so it's more clear. As you can see, before and after, if you go back in the video, the lengths are different. Here's a setup shown with a different camera. The picture quality is not as great, but basically it's showing you the lengths. Now, right, we have H as the length of the real length, basically, and we have H bar as the length of the apparent length or apparent height. The next thing we have is X, which is the distance from the ruler to the vertical line from the camera. So that is X, and the distance from the water, the level of water to the camera is y. So these are all the things that you need to keep in consideration. Is also shown in your refraction manual. Next, we're going to see how to actually measure the apparent height. So for this, I'll just use the picture that I took, the screenshot on my phone. So I'm using an actual physical ruler, and I will compare the lens as they appear in my camera before and after. So before it was around like 2-ish centimeters, and now, as you can see, is like less than 1 centimeter. So by using the ratio of the apparent to the real height in the camera with your apparent and real height in actuality, you can find out the apparent height, the physical apparent height, and you can use this to find out the refractive index of water. Right, this is the end of the demonstration. Good luck.